Sometimes the smallest mistake can lead to the biggest disasters. We like to think of the universe operating with these elegant laws of physics, and for the most part, it does. But here on Earth, when humans try to get involved, well, things can go sideways pretty fast. Today we'll look at 6 incredible instances where tiny math errors caused massive consequences. Buckle up. We're going to start our journey with a trip to the dawn of the jet age. The de Havilland Comet, a sleek, beautiful machine, promised to revolutionize air travel. This was it, the future, faster flights, smoother rides, what's not to love? But then, 1954 hit. 2 comets disintegrated mid-flight, 56 people lost their lives. Now, when a brand new piece of technology catastrophically fails, you know engineers are going to be up all night trying to figure out why. And figure it out they did. The culprit, believe it or not, it was the windows. Square windows, to be precise. Seems harmless, right? But here's the thing, square windows created weak points in the fuselage. Every time the plane pressurized and depressurized, stress was concentrated at the corners of those windows. It was only a matter of time before metal fatigue led to cracks, and eventually, disaster. And you know what's amazing? The engineers, they quickly realized that curved windows distributed the stress more evenly, preventing those cracks. A simple change in geometry, a curve instead of a right angle, meant the difference between soaring through the sky and, well, plummeting back to Earth. Let's talk about aircraft carriers. Imagine trying to land a plane on a relatively small, moving platform in the middle of the ocean. Talk about pressure. Now imagine doing that when the runway is also cluttered with planes. That was the reality for Navy pilots before 1952. Landing was more dangerous than it needed to be. Planes would touch down, only to collide with others because there simply wasn't enough space. But then, an unsung hero, probably an engineer, had a light bulb moment. Their solution? A 9-degree angle. Yep, you heard me right. Just tilting the landing strip by a mere 9 degrees made a world of difference. This ingenious tweak allowed pilots to land safely, even if the rest of the runway was occupied. It also meant that carriers could launch and recover aircraft simultaneously, making them far more efficient and much safer. It's a beautiful example of how a small, almost unnoticeable change can have a massive impact. The year is 1981. The Hyatt Regency Hotel in Kansas City was buzzing with excitement. A dance competition was in full swing. The atmosphere was electric. But in a heartbeat, that joy turned to horror. A walkway packed with spectators collapsed, sending people plummeting to their deaths. 114 lives were lost, and countless others were injured. Now, what caused this horrific tragedy? A seemingly insignificant design change. The original blueprints called for a single long rod to support 2 walkways, simple, elegant, strong. But somewhere along the way the design was modified. Instead of 1 long rod, they used 2 shorter rods. Sounds harmless, right? But here's the problem, this change doubled the load on one of the supports. It was now carrying twice the weight it was designed to handle. And on that fateful night, it gave way, resulting in one of the deadliest structural collapses in American history. It's a stark reminder that even the smallest design alterations can have unintended and utterly devastating consequences. Chapter 4: The Night the Music Died. 1942, the Coconut Grove nightclub in Boston was the place to be. People were dancing, laughing, enjoying their evening, but then tragedy struck. A fire broke out, and within minutes the entire club was engulfed in flames. 492 people perished that night, making it the deadliest nightclub fire in U.S. history. Now, while the fire itself spread with terrifying speed, the true culprit in this disaster was something much simpler: the doors. You see, the doors to the Coconut Grove opened inward. So, when panic erupted, as it inevitably does in a fire, people instinctively pushed against the doors to escape. But because they opened inward, the more people pushed, the more jammed the doors became, trapping hundreds inside the inferno. It's a chilling reminder that sometimes, the most obvious solutions are the ones we overlook. Had the doors simply opened outward, countless lives could have been saved. Chapter 5. When Bridges Dance with the Wind. Let's rewind to 1940. The Tacoma Narrows Bridge, a magnificent suspension bridge spanning Puget Sound in Washington state, was a marvel of engineering. But there was just one problem: it had a bit of a dance move, and not the good kind. You see, this bridge had a tendency to sway and ripple, even in relatively mild winds. Now, engineers at the time weren't overly concerned. They thought the flexibility was, well, a feature, not a bug. But on November 7, 1940, the wind picked up, and the bridge decided to put on a show. It began to oscillate wildly, twisting and turning in ways that bridges simply shouldn't twist and turn. And then, in a scene straight out of a disaster movie, the bridge collapsed, plunging into the water below. The culprit, a phenomenon known as aeroelastic flutter. Basically, the wind was hitting the bridge in just the right way, creating vibrations that amplified until the structure couldn't take it anymore. The fix? Believe it or not, something as simple as adding wind holes to the bridge's design. These holes would have allowed the wind to pass through, reducing the force of those vibrations and preventing the catastrophic collapse. Chapter 6. The Ship That Couldn't Turn. We've all heard the story of the Titanic, the unsinkable ship that met a tragic end in the icy waters of the North Atlantic. But what if I told you that a simple design flaw might have played a role in its demise? Let's set the scene. It's a cold April night in 1912. The Titanic, on its maiden voyage, is sailing through an ice field. Suddenly, an iceberg is spotted dead ahead. The crew scrambles to avoid a collision, ordering the engines to reverse and the rudder hard to starboard. But here's where things went wrong. The Titanic, a marvel of engineering, had a design quirk that would prove fatal. Its center propeller, the largest of its 3 propellers, couldn't reverse. So, while the outer propellers were fighting to pull the ship away from the iceberg, the center propeller was still pushing it forward. This created a phenomenon known as propeller walk, essentially reducing the rudder's effectiveness. The result? The Titanic, unable to turn quickly enough, grazed the iceberg, sealing its fate. It's a haunting reminder that even in the face of monumental disasters, the smallest details, those seemingly insignificant design choices, can have unimaginable consequences. Outro, the devil's in the details. In each of these cases, a small math or design error led to a disaster. It shows that even the tiniest oversight can have profound consequences. The lesson here? Pay attention to the details, because one small mistake could change everything.